college algebra lesson of the semester, we're going to finish up talking about conic sections, specifically the hyperbola. The hyperbola is the set of all points in a plane for which the absolute value of the difference between the distances of two fixed points, the foci, is constant. And the midpoint of the segment between the foci is what we call the center of the hyperbola. When we're looking at the center being the origin, we're going to have slightly different standard equations than if our center was somewhere else, and we'll talk about that in a moment. Let's also look at the similarities between the hyperbola and the ellipse. A similarity is that we're going to have x squared over a squared or x squared over b squared depending upon the transverse axis, how it looks. Further, it's equal to 1. Now, some difference is that with an ellipse, we are adding our x squared and our y squared portions. And when we're looking for c squared, we are adding a squared and b squared, where with an ellipse, we are subtracting. So very different. We also can identify the asymptotes given. As long as we know an a and a b, we can find our asymptotes depending upon which transverse we're looking for. So let's find an equation of the hyperbola with our vertices of 0, -4, and 0, 4, and the foci of 0, -6, and 0, 6. So notice in these two places, we know the y value. So that will help identify which type of transverse we're going to have, a vertical or horizontal. Notice that because we know the y values, when I'm looking at my two equations, I can tell then that we're going to have a transverse vertical axis here. I know that based on my vertices here that a is going to equal 4, and that c, because of the foci, we know is going to equal 6. We also can find out what b is, since we need b in order to write our equation, because c squared is equal to a squared plus b squared, or 36 is equal to 16 plus b squared. And 20 is equal to b squared. So then b is equal to the square root of 20. However, because we're writing our standard equation using the squared versions here, we will have y squared over a squared. A squared would be 16 minus x squared over b squared. Well, the square root of 20 would be 20 when we square it, is equal to 1. So let's just draw a quick sketch of what this might look like. We know our vertices are 0, 4, and 0, -4. We also know our foci are 0, -6, and 0, +6. So it will look something like this. It didn't ask us to find the asymptotes. We're going to get to that in an example, but just so we can get a general idea of the picture of what we're working with. And again, this origin is our center is at the origin. On our next page, for the hyperbola given by 9x squared minus 16y squared equals 144, let's find the vertices, the foci, and the asymptotes, and then graph the hyperbola. So I've got it graphed already so we can get an idea of what it looks like here. In order to find the equation and utilize the standard form, I need to get this piece needs to be 1. So I'm going to multiply everything by 1 over 144. When I do that, I'll have 9 over 144, which simplifies to x squared over 16, minus 1 over 44 times -16 will give us y squared over 9 equal to 1. Rewriting these in the form of squares, 16 is the same as 4 squared and 9 is the same as 3 squared. Since our x squared comes first, I know that I'm going to have a horizontal transverse. And I know my A is 4 and my B is 3. So I know my vertices then, utilizing the formula from the previous page, are going to be negative 4, 0, and 4, 0. So here are my vertices. In order to find my foci, I need the C value, but because I only know A and B, we can utilize C squared is equal to A squared plus B squared, so that I know that C is equal to 5 when I take the square root of 25. So that my foci are negative 5, 0, and 5, 0. So here's a foci, and here is our second foci. We can find the asymptotes utilizing the formulas y is equal to b over a times x, and y is equal to negative b over a times x. We know our b and our a value from the standard form. So our equations will be y are equal to 3/4 x and y is equal to negative 3/4 x for our asymptote equations. So here, the green line here would be 3/4 x, and the orange line here would be our second asymptote of negative 3/4 x. Now, when our equation is not at the center, we still need to have HK. We have very similar pieces to the standard form at the center, at the origin. However, we just have a few extra pieces when we're talking about finding the asymptotes, vertices, and foci. Okay, so let's look at an example of what that might look like. For the hyperbola given by 4y squared minus x squared plus 24y plus 4x plus 28 is 0, we need to find what is the center, the vertices, the foci, and the asymptotes, and then draw the graph, which I've got listed already for us down below from Desmos. I'm going to rearrange these so that my x values are together and that my y values are together. So when I look at my x values here, I'm going to have negative x squared plus 4x, and my y values together are 4y plus 24y. So with my y values, since those were positive, I'm going to put them first. Notice that my y values are both divisible by 4. So I'm going to divide 4y squared plus 24y by 4. Leave some space because we're going to have to complete the square to finish these. And with my x squared, I'm going to take out, since we need to be in subtraction for our standard form, I'm going to divide both negative x squared and positive x by a negative, which would leave me with negative x squared minus 4x. Leave some space, and then subtracting 28 onto the right-hand side. Now let's complete the square. I'm going to first take 6 divided by 2 and square it. That gives me 3 squared, which is 9. Okay. So when I put 9 on the left, or the left-hand side, to multiply the 4 times the 9 in order to bring it to the other side, just like we did in our previous example. So 4 times 9 we know is 36, so I'm adding 36 to the left-hand side, so I need to add 36 to the right-hand side. And I'm just going to cross off this line here because we've just talked about that, as well as this line here as well. Since it'll already be talked about, we're kind of doing multiple steps at one time. All right, now we need to look at x squared minus 4x and complete the square here. So I'm going to take the negative 4 piece here, divide it by 2 and square it. That gives us -2 squared, and keep in mind this -2 will be the part when we factor, and that gives me 4. So I'm going to add 4 to the right-hand side with my x's, but just like on the left-hand side, when I take -1 times 4, I end up with -4. So if I'm subtracting 4 on the left, I need to subtract 4 on the right-hand side when we combine like terms. All right, going ahead now and factoring, I'll have 4 times y plus 3. Again, the y plus 3 coming from here, minus x minus 2 from the right-hand side is equal to 4 when we add all of our pieces together. Okay. Also, I now need to look at this 4 here. We know that this 4 needs to be a 1. So I'm going to multiply everything by 1/4 so that I can make that 4 on the right-hand side equal to 1. Well, 1/4 times 4 times y plus 3 squared is going to be, we'll cancel and just have 1 in our denominator. When I multiply 1/4 times our x minus 2 squared portion, I'll have 1/4. And 1/4 times 4 then is 1 itself. We know this is going to be a vertical transverse because our y squared comes first. We can put it into standard form because we need to find where the center of our hyperbola is located. So we need our k and our h value. I have y plus 3, but placing it into y minus a value gives me y minus a -3. So now I know my k value. I also know my h value is 2. I know my a value, and I also know my b value since 2 squared is 4. My center is at hk, or 2, -3. My vertices are found by taking h with k minus a and h with k plus a, or 2, -4 and 2, -2. Our foci comes from h and k minus c and h k plus c, but I don't ideally know where my c value is. But I do know that c squared is equal to a squared plus b squared. So c squared is equal to 1 plus 4, or 5. When I simplify, c is then the square root of 5. So I'll have 2, -3 minus square roots 5, and 2, -3 plus the square roots of 5. We also can find our asymptotes using the following equations. Y minus k is equal to a over bx minus h. I know my k value is a -3, and when I take a over b, I have 1 over 2 and times x minus our h value, which is 2. Simplifying, I have y plus 3 is equal to 1/2 x times x minus 2. And if you so choose, you could subtract 3 and get y by itself, but you don't have to. As well as y minus k is equal to the opposite of a over b. So we'll have the opposite of 1/2 with everything else the same as well. So stick to utilizing the formulas. They will help you. Which values are you supposed to use? H's, K's, A's, B's, and C's. So keep them close by so that you can work through these more easily. And this concludes our lessons on conic sections.